Hello students, I welcome you. Sample paper question 2021-22 term 2 chemistry theory 0543 12th class chemistry students. Pay attention, stay focused and concentrate. I would be solving the sample paper released by the CBSE. As you will see, the maximum marks 35, time 2 hours. First thing is that we should read the general instructions. Read the following instructions carefully. Read the following instructions carefully. Let us read it carefully. There are 12 questions in the question paper with internal choice. Internal choice has been given. Section A. Section A contains question 1 to 3 are very short answer question. You don't have to write too much, students. Very short questions carrying 2 marks each. Section B, question number 4 to 11 are again short questions, short answer questions carrying 3 marks each. Section C is case based question carrying 5 marks. All questions are compulsory, but internal choice has been given. Use log tables and use of log tables and calculators not allowed. Not allowed. Our duty, our responsibility, as soon as you go to the examination hall, stay relaxed, stay relaxed, close your eyes, breathe in, breathe out, deep breathe in, deep breathe out, prayer, and then you are relaxed. Read the instructions very carefully. After you read the instructions, then we will attempt the questions which, as because internal choice is given, so the question which you are sure you should do that, and doubtful questions don't do that. Okay, let us start section A today, students. Section A is on the screen. First question, arrange the following in increasing order. Now read each and every word, each and every line carefully before you answer the question. Arrange the following in increasing order. Increasing order, I have noted the point of the property indicated. Any two. You have A, B, C. You can answer any two of the three. So you should read all the A, B, and C choices, and the best two, you are sure, answer that. And you can see the marking scheme 1 into 2. So that means each will be given 1. Only 2 you have to answer. 1 plus 1 becomes 2. Clear? This information is there. First question is, you are given benzoic acid. I'm talking of answer A, student. Let me see benzoic acid. At phenol, picric acid, salicylic pKa values. Now, what do you mean by pKa values? You already know, student. pKa is equal to minus log of K. You know already, student, stronger the acid, larger the Ka will be more, and stronger the acid, pKa will be smaller. This information is already known to you. You have already know the acid base theory, conjugate acid base theory. You know, you have studied Lowry-Bronsted theory, is very important. It is used. What is happening, student? Acid will lose a proton and form a conjugate base. If the conjugate base is stable, then it is a stronger acid. The more strong the conjugate base, the stronger is acid. In such cases, let us see what are the structures of these. It is very important that we should be able to know the structures. See the benzoic acid, students. You know, carboxylic acids are strong acid. You already know carboxylic. Certain information is already known to us, student. These carboxylic acids are stronger acids than alcohols and phenols. You know, than phenols and alcohols. You know the conjugate acid base theory, because the conjugate acids are, what happens in carboxylic acid, resonance stabilization. You are aware of that carboxylic acid are so strong acids that they even exist as dimers. Even in the vapor phase there is a hydrogen bonding also which takes place. Now what is happening, student? This is our benzoic acid. If it loses a proton, it will form carboxylate, and you can see this is a resonance stabilization, and the 2 oxygen here, negative charge, this will be. And also there is an aromatic benzene system, which is a sink of the electrons. You already know. So the stronger the conjugate base, electron withdrawing groups increases the acidity, and electron releasing group decreases the acidity. So because they will intensify the negative charge, the negative charge of the conjugate base, and it will become less stable. So you have benzoic acid, you already know about that. This is our phenol, students. Benzoic acid, I am trying to explain everything. This is our phenol, student. If proton is removed, it will form a phenoxide ion that gets resonance stabilized by the aromatic benzene ring, is a sink of electrons. Then you have picric acid, very important. There are 2,4,6 trinitrophenol. And what you know about this, students? Okay, let me put it like this. So what is happening, student? In this case, these are three electron withdrawing groups. They are strong electron withdrawing groups. You will see these are three strong electron withdrawing groups, student. So what they do, they can withdraw the electrons by minus I as well as minus R effect, resonance and electronic, the two electronic effects which are operating. Inductive effect, electron, nitrogen, oxygen, they are strongly electronegative and they can pull the electrons, and also resonance is operating. So you can see, then this is the picric acid, then you have salicylic acid. What is the formula of salicylic acid, students? If I say this is my COOH and this is OH, here you see in this case there is a ortho hydroxy effect also, and once it will lose a proton, also it will form a hydrogen bond that will make it more stable, that will make the conjugate base also stable. So now it is clear, student, out of this which will be the strongest acid. The strongest acid, there are three nitro groups which are strongly electron withdrawing by the inductive as well as by the resonance. So this is our number one. This is the strongest acid. In other words, this will have pKa lowest pKa. And after this, student, what will come after this? You will get at number two. This is my salicylic acid. Number two is my salicylic acid, and then number three is my benzoic acid, and number four is my phenol. In this case, carboxylic acids are more stronger acids than phenols and alcohols. You already know, we have already told you. Therefore, student, in other words, which will have the lowest pKa, we have to arrange in increasing order. What is said? Increasing order. Increasing order, what do you mean by increasing order, students? Try to understand everything. Increasing order is like this, students. This is the increasing order. Now the lowest pKa, strongest to the acid, the pKa is lowest. So this is our, this, which is this picric acid. So if I have to arrange, student, I can say picric acid. This will have the lowest pKa because it is the strongest acid. After that, what will come, student? After this is coming salicylic acid, and after salicylic acid you will get benzoic acid, and after benzoic acid, student, what you will get? Phenol. Increasing order, because you have to arrange in the increasing order. So this is our answer for A, student. So I have tried to explain you in clear, complete detail the electronic factors, how electron withdrawing groups will increase the acidity, and all the factors which are operating. So you already see, if you will check the pKa's, you will find the pKa of picric acid is a very strong acid. This is a very strong acid, and the pKa of this is around 0.3, student. And after that, the salicylic acid has a pKa of around 2.87. If we will check in the books the values, and benzoic acid has pKa of 4.19, and phenol pKa you already know, because this is a very important compound, is around 10. Phenols are more acidic than alcohols, you know about that. So this is very clear now. This is the answer for A. Now what is the next? B. Let us read the question very carefully, what it says in B, students. In B, saying acetaldehyde. What is acetaldehyde, students? CH3CH, acetaldehyde or ethanol. Acetone, what is the formula of the acetone, student? And methyl tertiary butyl ketone, student, what is that? So you have, these are the T butyl group, ठीक है, methyl, this is our methyl. So you again have 1, 2 and 3 compounds. We should be able to write the structure. Reactivity towards hydroxylamine, student. What type of reaction is this? You know, NH2OH, you know, these are examples of nucleophilic addition reaction. Nucleophilic addition reaction, students. You have studied the most important reaction of carbonyl compound is nucleophilic addition. The factors, what are the factors which will affect the reactivity? There are electronic factors and steric factors. Electronic and steric factors always. You are clear of that? What do you mean by this, student? You can see the attack is going to take place on this carbon, student. This is positive and this is negative. And more positive it is, more positive it, more the reactive. So aldehydes will be more reactive than ketones. But there is a steric factor. As the bulkiness will increase, the attack will become difficult. So there is a steric inhibition. You can see maximum steric inhibition is in this. So this will react the least. And after that, ketones and aldehydes, there is a less steric hindrance, and also the here plus I effect is operating. Only one methyl group, there are 2 plus I effects here, and here also you can see the plus I effect. So plus I effect and steric factors. So now it is clear, student, your answer, the nucleophilic addition will be fastest in the case of aldehyde. And what will be the result of that? So if I have to arrange, students, be careful, then what will be the order? Increasing order again. So you have acetaldehyde, and after that you have acetone, and then the least reactivity will be methyl, students, tertiary butyl ketone. This is a nucleophilic addition reaction. I hope you understand. Try to understand everything. Understanding is very important because questions will be changed in the paper, but this is the way how do we answer the question. So B is answered, student. And next I am coming to the C. Ethanol, ethanoic and benzoic acid boiling point, student. Boiling point question is always there in the paper. And you already know what do you mean by boiling point. Wherever there is a strong intermolecular hydrogen bonding, the boiling point rises. So what factors are there for the boiling point? Factors. One is, student, intermolecular hydrogen bonding, where it is maximum, you already have seen carboxylic acids have strong intermolecular hydrogen bonding, so much so they are existing as dimers. Even in gas phase there is a strong intermolecular hydrogen bonding. So carboxylic acids are stronger acid than alcohols. They are carboxylic acid have higher boiling point than alcohols because their intermolecular hydrogen bonding is very strong. And further, it depends on the molecular mass. The larger the molecular mass, students, larger the molecular mass, what will happen? The stronger will be the boiling point. So in this case, it is clear that carboxylic acid have larger boiling point than alcohols, but there are 2 carboxylic acids. But you will see that the benzoic acid has a larger molecular mass as compared to ethanoic acid. So the order should be like this. The factors which I have used, what factors I have used, students? The steric molecular mass and intermolecular hydrogen. I hope everything is clear. So we have been able to answer the 3 parts, A, B and C. Let us see the answer given by the CBSE marking scheme. So students, the answer which is given by the CBSE is here. This is a marking scheme. Let us see the marking scheme which is given by the CBSE. First answer, picric acid, pKa. pKa is least because it is the strongest acid. So the pKa is increased. What is happening? pKa increasing order. And here this is the increasing order of the nucleophilic addition reaction. Increasing order because the question was increasing order. These are examples of nucleophilic addition reactions. You are getting 1 mark. if you write this answer, that's the only answer you have to write. I have tried to explain it so that questions will be changed and you should have complete knowledge of what you are doing, students. Is a chemistry means understanding chemistry is science. It is not a mugging or no mugging. Here concepts are involved, electronic factor, steric factor, all this you should know. Where when questions will be there on boiling point, you know it is intermolecular hydrogen bonding. What type of intermolecular hydrogen bonding is there? Molecular mass also, if it increases, the van der Waals force is increased. You know all these factors which decide the properties which they have asked for. Factors, they are very important. Try to have complete knowledge. So ethanoic acid, this is the order, and again what it says, boiling point of carboxylic acid is higher than alcohol due to extensive hydrogen bonding. Boiling point increases the molecular mass. In this question it looks to me like this, half and half, because here answer and the reason, this is the answer and this is the reason. So I have explained in detail answers and the reasons. So if they put it like this in the exam, half, okay, that question is answered. Let me go to question number 2, students. This section A, solution of 2 electrolytes, students. What is an electrolyte, students? Which can ionize. Electrolytes are those substances which can ionize. As soon as you put in water, what will happen? They will get ionized. 2 electrolytes are there, A and B, student. And he is talking of molar conductivity. Molar conductivity of B increases 1.5 times. Increases. He is saying increases. And that of A increases 25 times. This is increasing 25 times, student. Which of the two is a strong electrolyte? I'm stopping here. You have read, student, in NCERT, variation of this question is based on variation. You can open your NCERT book while I'm taking this class, solving the paper, and see variation of molar conductivity with concentration. Here I am talking of dilution because effects are always talked on dilution. You know that what happens on dilution? Molar conductivity, student, lambda m increases with the dilution. And again, we should know what are the factors, student, which will decide this. What are the factors due to which it increases? You know, there are ions. It depends on the number of ions, students. More ions, if there are more ions, then there will be more molar conductivity. If the number of ions increases, the molar conductivity will increase. In 1 mole, if there are more ions, molar conductivity of 1 mole of an electrolyte, 1 mole of an electrolyte. If there are more ions, it will have more molar conductivity. And if the number of ions remains the same, but there are inter-attractive forces between the ions, inter-attractive forces between the positively charged ions. And on dilution, what happens? These inter-ionic attractive forces diminishes, become less. So ions can move faster because in the path they have less inter-attractive forces. So these two factors will be there. Now what happens, students? You are aware a strong electrolyte like KCl or NaCl, and we are assuming is almost I'm saying completely ionized, is almost completely ionized. So there are already complete ionization, but on dilution, what will happen? There will be small increase in lambda m, students. There will be small increase in lambda m due to the inter-attractive forces force between oppositely charged ion will decrease. So there will be small increase on dilution in the case of strong electrolytes. So where is a small increase? 1.5. This is a small increase. So it should be the strong electrolyte, student. One question number is answered here. So what we are saying, B B is a stronger electrolyte, which is B is a stronger electrolyte, student. And A, what happens if it is a weak electrolyte? Let me take acetic acid or formic acid. These are weak electrolytes. Their ionization, a degree of ionization is very small. So less than 5%, very, very less ionization is there. So what will happen on dilution? On dilution, in the case of weak electrolyte, students, there will be a steep rise in lambda m on dilution. On dilution, students, on dilution, because there will on dilution, the more and more ionization takes place, and at infinite dilution this will become completely ionized, highly, almost completely ionized at infinite dilution. Therefore there will be a steep rise on dilution, and in this case this 25 times means 25 time increase means this is a weak electrolyte, weak electrolyte. Therefore A is a weak electrolyte, student, and B is a strong electrolyte. Now this is question and I get 1 mark only, because he says justify your answer graphically show. So now he wants a graph, student. So you already know, student, how you draw the graphs. I have taken more space, but anyway I am going to show. You have seen, student, the graph of molar conductivity versus the square root of the concentration. This is my moles per liter, student, 1/2, and molar conductivity you already know, student, Simon centimeters square mole inverse. So what happens if I take a strong electrolyte? You will get something like this, student, like KCl or Na. There is a slight increase on dilution, but for a weak electrolyte, you know what happens, students. This is a weak electrolyte. There is a steep rise. There is a steep rise, student, here. As you can see, this is our weak electrolyte. Strong electrolyte, this is a strong electrolyte, B. So, and this is our weak electrolyte, A, student, because there is a steep rise. As more ionization takes place in this case, when the electrolytes are diluted at infinite dilution, it is highly ionized. So the number of ions increases steeply, and there is a steep, you can see, increase. And you will see that you can never get the limiting molar conductivity. I'm just telling you, this is not a question here. In the case of weak electrolyte, that is why Coleridge law of independent migration of ions was used for that case. In this case, you can extrapolate to get the limiting molar conductivity, that is the molar conductivity at infinite dilution in the case of strong electrolyte. So here only 1.5 times increase, and here, student, you are getting more than 25 times. So you can see there is an abrupt increase. So I hope the question is answered and understood. This is an important question. Such questions will be there in the exam, students. So we should know the answers and understand. Let me see the answer which is provided by the CBSE marking scheme, student. The answer, as we said here, you have already answered. In B is a small increase, B is a strong electrolyte, we have answered. So when you said B is a strong electrolyte in the exam, you write B strong electrolyte, student, and you are given half marks. And the graph which we have shown, student, this is lambda m versus key mole per liter, the square root, and you have seen Simon centimeter square mole inverse. So all this information is known to us, students. You can use your NCERT if you have any doubts. So these are the units also I'm writing, and this is the graph. If you draw the graph, you will get half mark. So total half plus half gives you 1. Unless I understand, I cannot answer any question. This is very, very clear from me. I will take more time to explain to you, so that such questions are likely to be there in the paper, student. This is, for KCl, NaCl, etc. They are strong electrolytes. Strong. They are almost completely ionized, we are saying, and they have very low ionization, like acetic acid and carboxylic acid. These are mostly carboxylic acids. In organic chemistry, you have studied. They are weak weak acids, ionization is less than 5%. And in the case of the strong electrolytes, you know the equation which had been given in the book also, what they say, limiting molar conductivity minus a square root of c. So here they are the factors. The ions are the equation, just to tell you. Okay, I'm moving to the third question in section A, students. What is the third question? He says give reasons. Read the questions very carefully. Reasons, student. We have to write a presence of alpha hydrogen in aldehydes and ketones. Alpha hydrogen. What is an alpha hydrogen? What is an this is my ketone, for example, or an aldehyde. You have this hydrogen next to its student. You can see that. So it can be, if it is CH3, then it becomes a ketone. If it is H, it is aldehyde or ketone. Okay, alkyl group. Now what is this? This is my alpha hydrogen, student. This carbon next to it is essential for aldol condensation. What is now the question is, what is aldol condensation? You have studied aldehyde, and what you get is OL stands for the OH group and ALD. So what you are getting in these the products you already know. In the case of aldol condensation, what you obtain, student, beta hydroxy aldehyde or ketones. So what you call them as ketol or aldol. So aldol or ketol. You are aware of that reaction, but that reaction involves, students, again, these are examples of nucleophilic addition reaction. This reaction involves a carbon ion which is formed. Unless the carbon ion is stable, the reaction cannot take place. Now these alpha hydrogens are acidic, students. They are acidic. Why they are acidic? Because of the presence of CO. This is strongly electron withdrawing group. There is a strong electron withdrawing group. What will happen? If a base is there, student, this is my base. It will pull this. It will pull this proton, student. And then what will happen? It will form. What is this? Carbon ion. This will form, student. What is this base going to form? Carbon ion. This is a carbon ion, student. This has a negative charge. This gets resonance stabilized. So what you are getting here, students, you can see that this is a resonance stabilization of the carbon ion. Resonance stabilization of the carbon ion and then this attacks this carbon negative charge. This is going to attack the another molecule of aldehyde or ketone, and then aldol condensation takes place. So the answer is clear, because alpha hydrogens are acidic due to presence of a strong electron withdrawing carbonyl group. Therefore, they undergo aldol condensation. This is the answer for A. Alpha hydrogens are acidic. So minimum requirement, there should be at least one alpha hydrogen in order for the aldol or ketol condensation to take place. Otherwise, carbon ion cannot be formed, or it is not resonance stabilized, and then this condensation is not possible. I hope that answers the question, student. Let me see the B part. He's saying 3-hydroxypentane to 1 shows positive tolerance test, student. Tolerance test is very important, repeatedly asked in the exam. Tolerance reagent test. You have seen silver mirror in the chemistry lab. Tolerance reagent test. What happens when ammonical solution of silver nitrate, student? I have already uploaded video on this tolerance reagent test, the reagent involved. So what is happening here? This is a ammonical silver. What is happening here, student? Tolerance reagent test. This is a mild oxidizing agent. Mild oxidizing agent, student. So what will happen? Then it oxidizes aldehydes. You know, aldehydes have, these are our aldehyde, student. This hydrogen can be easily oxidized by mild oxidizing agents like silver nitrate. When in the solution, what it forms, student? Ammonical silver nitrate and AgNH3 twice plus. And what happens? Ag plus gains one electron and it undergoes a reduction, and then it undergoes a reduction and it acts as an oxidizing agent, but is a mild oxidizing agent. It can oxidize aldehyde but not the ketones. But here he is talking of 3-hydroxypentane. What type of this? What do you mean by 3-hydroxypentane 2? If I write 1 2, this is the 3-hydroxy, 1 2 3 4 and 5, students. This is our. Now what happens here, student? Because this carbonyl group is there, these hydrogens are going to be acidic because this is a alpha hydroxy. So 3-hydroxypentane, these are examples of what? This is a alpha carbon, alpha carbon. So alpha hydrogen attached to alpha carbon, this alpha carbon, student, hydrogen is acidic. And what happens? The mild oxidizing agents oxidizes this to an aldehyde. There is a, by the process called tautomerism. So these alpha hydroxy ketones, what I am trying to say, student, now understand. Alpha hydroxy ketones, they are oxidized, students, by Tollens reagent, ammonical silver nitrate, to aldehydes. Hence, they will give positive Tollens reagent test. They will give positive Tollens reagent test. If you want to study the complete mechanism, you can get it. But is here we are not interested in that, because you can see this question is carrying only 1 mark. So 1 mark is for this and 1 mark is for this. So you get 1 plus 1, 2 marks, student. Let me see the answer given by the CBSE. What is the answer here? He says the alpha hydrogen atoms are acidic in nature due to presence of electron withdrawing carbonyl group. We have explained in great detail. This can be easily removed by a base, and carbon ion is resonance stabilized. We already shown you the resonance stabilization of this. Solvent's reagent is a weak oxidizing agent not capable of breaking carbon-carbon bond in ketones. So it cannot oxidize ketone because there is no carbon hydrogen. There is a difference between carbon hydrogen and carbon-carbon bond, student. This can be easily broken by mild oxidizing agents. Mild oxidizing agent like Tollens reagent. Tollens reagent is ammonical silver nitrate, a mild oxidizing, and this bond cannot be broken, student. It cannot be broken by mild oxidizing like Tollens reagent. The ketone cannot be oxidized using itself, gets reduced to silver. Okay? Using Tollens reagent as silver, we have already shown you what happens in the process. Silver gains 1 electron and gets reduced this. So, but we have shown you that alpha hydroxy ketones, they tautomerize in the presence of this, form the aldehydes, and hence they can show the positive Tollens reagent test. So this is the section A, student. I hope we have explained in great detail, and then I will give another video for section B in next time. Thank you very much. Pay attention, stay focused, concentrate, try to understand. No mugging is required. Read the NCERT thoroughly, each and every word, each and every page. And your paper will be NCERT based, but questions can be put with intelligence. Therefore, I would say pay attention to each and every word of the NCERT book and try to read as much as possible. Understanding is very important in science, in chemistry, in physics, and bio. Mugging is out. It doesn't work in any of the questions which have been asked. and you have seen the marking scheme, and you have seen you have to write limited, but you have to write, this is a descriptive paper, so you should have a practice of writing correct answer, specific correct answer. If you don't write the correct answer, no marks will be allotted. Okay, bye bye, we'll see you next time.